Hello, Year 10. One or two of you have been in touch about the most recent MyMaths homework. I think it was for lesson 3D shape 6, and in particular the very last question to do with the pyramid. Now, the first thing that I want to make super clear to all of you is this is incredibly challenging maths. If I was to give this a GCSE grade, I would call this pyramid question a grade 9 question for sure. Now, there's also a few problems with MyMaths in regard to this question, because if you think about it, MyMaths gives you marks for the final answer. And in a question like this, in an exam, there would be lots of marks for in-between working out. And MyMaths can't differentiate between your final answer and what your working out might have looked like. So although some of you might have been getting 0, in terms of the marks from MyMaths for this, if you'd done some working out, it's very, very likely you would have got some marks. And the second thing about this is a lot of you will be having the problem of actually trying to picture exactly which angle it is wanting you to find. So when it says find the angle between the planes AVB and ABCD, well, which angle is that? What does that angle look like? I'm just going to try and take a little bit of time before I actually walk through the solution to one of these questions to try and explain this is the angle that it means. Okay then, so let me just swap screens. Okay, so what I've done is I've made a very, very simple representation of part of this pyramid. Okay, and I've done it as a net. So I've got my square base, which would be my plane ABCD. And I've got one of my triangular faces. It's an isosceles triangle, but I've got one of my triangular faces, which would represent AVB. And obviously, and I'm not sure how well this will look on a visualizer, might go out of focus, we'll see. When you have a pyramid, that would be your square base, and this would be the sloping side. So when it's talking about the angle that we need, it is the angle between here and here. Okay, so that is the angle that it's asking us to find. But even when you know that, it can be then quite hard to picture what that looks like on a diagram. So what I want you to imagine is I have chopped my 3D pyramid in half, and I'm looking at it side on. I'm just going to do a quick little sketch of what that would look like. So just grab my pen. If I chopped my square base pyramid in half, let's get it in focus please, it would look something like that. Okay, and this is the angle that we need. But the question then remains, well, what does that look like when you then go back to your 3D diagram? Because if you can figure out which angle it is, I'm sure more of you would have had success with this question. So let's have a look. I've drawn some things out already for this one. So it's a complicated diagram, but this diagram here should look a little bit like what is on MyMaths. These numbers obviously might be different for you. Okay, this pink triangle here represents the triangle that I was just showing you a moment ago. Okay, you can imagine I've chopped it down the middle there, and this was the triangle that I had a moment ago. Okay, it might not look like it from this angle, but this is the right angle because this is the vertical height of the pyramid, and this is the middle of the sloping side of this face. So again, if you think back to what I've drawn here, this dotted line here is this dotted line here, and that is forming a right angle triangle. Okay, and it is this angle here that I have marked, that I have called VXE, that is the angle that I need to work out. In order to do that, I am going to have to do some extra maths with another right angle triangle, which is the isosceles face split in two. Now, from this point here, you might think, oh, that's enough, sir. I know what I'm doing. If that isn't enough for you, I'm now going to do the solution to the whole question as to how I would do it. Okay? Because in order to work out the angle, I will need to know some things. I will need to know two of these sides of this triangle. Well, I actually already know the length of XE. Because the length of XE, because this is a square-based pyramid, okay, is half of the sides of my square. And half of 12.4 sounds like 6.2. Now from here, you've got a couple of different options. You could work out the height VE. And you've probably worked out the height of some pyramids in some other questions, and you might be confident doing that. I personally think it's easier to work out the length of VX. And this is what I need my second green triangle for. Because I can work out the length of VX using Pythagoras. And I would always avoid using trigonometry if I can find something using Pythagoras. So, looking at this green triangle here, I know the length of XB is again half of the side of my square. So that is 6.2. And I actually know all the lengths of these edges that lead up to the vertex because it is 14.6 in my question. So this is 14.6, this is 14.6, this is 14.6. They're all 14.6. So there we go. Now, I can work out Vx using Pythagoras. It's a shorter side because I've already got the hypotenuse. So I can say that Vx squared equals 14.6 squared, take away 6.2 squared. Okay, this is where I'll reach for my calculator. So I'll try and do this so you can see on the screen. No, the light's bad, I'll put it there. So 14.6 squared, take away 6.2 squared. And that equals 174.72. And then obviously that was Vx squared, so I need to do the square root of that. And the square root of that, it's not going to be a very nice number. But at this stage, I will write out the whole number. And the reason why I'm going to write out the whole number is because I don't want to lose any accuracy at all. So the side there is 13.2 whatever. And that sounds sensible to me because it is less than the 14.6. So the Pythagoras is sounding good. So what that tells me is the length of Vx. So I now know on my pink diagram, this is 13.2 something or other. And now I'm in a position to use one step of trigonometry to work out my angle. So I'm going to label my sides. I'm trying to find theta, so VE is the opposite. 6.2 is the adjacent. And 13.2 is my hypotenuse. So, adjacent, hypotenuse, that is going to be a cosine question. So I'm going to write cosine theta equals adjacent over hypotenuse, 6.2 divided by my 13.2, blah, blah, blah. And remember, when you're using a calculator and you're finding an angle, you need to use your second function button. So, I am going to do cos to the minus 1 of 6.2 divided by all that answer that I wrote out there, 13.2181691 equals, and it wants it to the nearest degree, so the answer to my pyramid will be different to yours because the chances of getting the same numbers are very, very slight. 62 degrees. But like I say, the key to this question is knowing exactly which angle it is the question is asking you to find. And I'm sure some of you will have done some great maths. So should this have been an exam question, you would have picked up some marks for what it was that you were doing. Okay? So, thanks folks. Do keep in touch if you want more videos like this helping you out. Or if you want, I did some scaffolding sheets earlier in the week where I talked you through how to do it without actually doing it. I can do some more activities like that for you. But signing out for now. Goodbye.